A collision is the event in which two or more bodies exert forces on each other about a relatively short time. Although the most common use of the word collision refers to incidents in which two or more objects collide with great force, the scientific use of the term implies nothing about the magnitude of the force.
There are two general types of collisions in physics, which is elastic and inelastic. The definition of elastic is an elastic collision is an encounter between two bodies in which the total kinetic energy of the two bodies remains the same. In an ideal, perfectly elastic collisions, there is no net conversion of kinetic energy into other forms such as heat, noise, or potential energy. The definition of inelastic is an inelastic collision occurs when two objects collide and do not bounce away from each other. Momentum is conserved because the total momentum of both objects before and after the collision is the same.
Potential energy. Potential energy is the energy that is stored in an object due to its position relative to some zero position. An object possesses gravitational potential energy if it is positioned at a height above or below the kinetic energy. The kinetic energy of an object is the energy that it possesses due to its motion. It is defined as a work needed to accelerate a body of a given mass from rest to its state velocity. Having gained this energy during its acceleration, the body maintains this kinetic energy unless its speed changes.
Conservation of momentum. General law of physics according to which the quantity called momentum that characterizes motion never changes in an isolated collection of objects. That is, the total momentum of a system remains constant. Momentum is equal to the mass of an object multiplied by its velocity and is equivalent to the force required to bring the object to a stop in a unique length of time.
In this problem, a cube lined up with elastic collision with another, so we will figure out where does each cube land. We're gonna do elastic collision here that tell us we have energy conserved and momentum conserved. To know where does each cube land, we need to find delta x. So based on the equation given, we will solve this problem based on projectile solution. What do we need to solve projectile problem? First, we need to find velocity when inclined for each cube. Let's start with energy. Energy initial equals to energy final. We must consider before the collision and after the collision. Well, this cube at rest, so we have potential energy, and at final we have kinetic energy. Potential energy equals to kinetic energy of both mass, which is kinetic energy of big M plus kinetic energy of small m. Next, just substitute formula of the potential energy and kinetic energy, which is mgh equals to 1 over 2 mva square plus 1 over 2 small m vb square. We need to substitute 1 over 2 big M into small m because the value was given in the equation. Here we come up with the second equation, which is VA equal to 1.98 minus 1 over 2 VB. To find the initial velocity, we need to use equation potential energy equals to kinetic energy right before the collision at the block M. Just substitute the equation as usual, and here we will get the answer of V0 equals to 1.98 meter per second. So we have two equations and two unknown. Just solve it in mathematical way. Substitute equation 1 into equation 2 and we will get the answer of BB equal to 2.64 meter per second and VA equal to 0.66 meter per second. So let's solve the problem in projectile solution. From equation, we can get delta T, V0, A, and what we need to find is T. We just need to substitute the equation
in delta t equals to v naught t plus 1 over 2 a t square. And then we will get the answer of the t. After getting the t value, we substitute into the equation delta x equals to v naught t, and then we will get the final answer of big M, which is 0.28 meter. We will do the same thing for block little m, and we will get the answer of 1.13 meter. For this equation, we're gonna use the same t because the block drop at the same time.
As a conclusion for this experiment, the elastic correlation of internal kinetic energy is conserved, so is the momentum. That means, in the course of collision between objects that have same mass, the first object that collides with static second object will come to rest, while the second object will move with speed equal to the first object. So, we can say that the lighter body will bombard back with its own velocity, while the heavier mass will remain static. In inelastic collision, the colliding mass stick together and move in the same direction at the same speeds. The momentum is conserved and the kinetic energy is changed to different forms of energies.